Welcome to Max Min's Applied example number 2. So here is the problem. A man wishes to fence in a rectangular plot lying next to a river. No fence is required along the river bank. If he has 800 meters of fence and he wishes the maximum area to be fenced, find the dimensions of the desired enclosed plot. I'm going to break down this problem a little bit. Basically, we've got a graph here, or an example of what the layout looks like. We're assuming that the river is basically straight and that we've got three sides of fencing. We've got a Y, an X, and another Y that we're going to need to use, and that total perimeter, or that side of the fence, is equal to 80 meters. Okay, breaking this down into some equations, we know the perimeter is equal to 800 meters. We can see that our perimeter, or our length of fence, is going to be a Y plus an X plus another Y, with the river as the alternate X, or missing X that we don't need. So we can simplify that to the perimeter is equal to 2Y plus X. Now we substitute in the total distance for the fencing. We've got 800 meters equals 2y plus x. And we also know that the area is going to be that the fenced area, which the farmer wants it to be maximum, the fenced area is going to be x times y. So if we take our perimeter formula and solve that in terms of either an x or a y, in this case we're going to solve it in terms of x, we get x equals 800 meters minus 2y. Now we substitute that into our area formula and we end up with an area equal to 800y minus 2y squared. Now if we take the derivative of that, we get 800 minus 4y. And we know that at our maximum, our slope should be 0 graphically at that maximum point. So if we substitute out 0 for the dA dy, we get 0 equals 800 minus 4y. Now we can solve for y and we get a y that's equal to 200 meters. So now we're going to do the same exact thing that we did in the previous slide, but we're going to end up solving for an x value. So we know our perimeter and we know that our area is x times y. And so if we set our perimeter equal to y, we try to solve for y in the perimeter formula, we get a y equals 400 meters minus x divided by 2. Now we can substitute that y into the area formula and we get x times parenthesis 400 meters minus x divided by 2. And now we can simplify that or distribute the x through and we get 400x minus x squared divided by 2. Now if we take the derivative of that, we get a 400 minus an x. Remember, a half times 2 equals 2 over 2, and then the number in that equation drops out, leaving us just an x. So now again we know that the max slope is when the slope is at 0, so we're going to substitute the 0 in for the dA dx and solve for x, x being 400. So now we have what we believe is the x and y that'll give us the maximum area. And if we want to find that area, we just times our x times y and we get 800 kilometers squared. So this is similar to, in this equation, we didn't do the original graphical analysis as we did in the previous examples. We just went straight to calculus. But if we want to check our work, what we can do is offset either the x or the y a little bit and then recheck and see what that gives us for an area. So what we're going to do, what I'm going to do here is we're going to bump up the y to 205, and then once we have y set at 205, we can now calculate for an x, and we end up with an x equal to 390. Remember, we're keeping the perimeter the same, and then we're going to check that area. So if we've got an area, our x of 390 and a y of 205, we multiply those two together, and we see that we get a 79.95 kilometers squared for our area, and we know that that is less than our 80 kilometers squared that we calculated previously, so we know that that's not our max. So now we're going to do the exact same thing, but we're going to move y to the other side of the original 200 meters. So we're going to roll it down 5 meters. So if y is equal to 195, we get an x of 410 meters. And we can see that 410 times 195 also gives us the 79.95 kilometers squared for the area, which is also not the max. And that also points to our original x and y as absolutely being the max. So the calculus worked, and then we just did a little quick check to see if that did look like it was at our max, and it is. So our area max is in fact 80 kilometers squared with an x at 400 meters and a y at 200 meters.